heard the phrase, you can't unscramble an egg. In other words, you can't go backwards. Well, you may not be able to do that with an egg, but you can go backwards with bearings. What do I mean? In this particular question, let's take a closer look. We are asked to find the bearing of O from A. In other words, we've got to go from here back to here. Now, what we are given is the bearing from here down to A. In other words, NOA, the bearing is 130 degrees. So we need to go backwards. Now, the first thing we do when we hear the magic word from is we need to draw in the diagram. We need to draw in the crosshairs on north, east, south, and west. Now, you've probably heard me say before that a problem well drawn is a problem half solved. So let's draw in the crosswords right over here at A. So I got my trusty ruler. There it is. And I'm going to draw in the crosshairs so we can take a closer look at this diagram. So let's draw the north-south first of all. There's our north-south, and then across here we'll just draw in the east-west. Let's put in our north. Okay, there's our trusty crosshairs. Okay, now let's put in the bearing. Now remember, bearings are very important because they start at north, and bearings are nothing without north. Okay, so let's do that. And that's going to go clockwise all the way across here, back to up there. There's the bearing that we are out after. Now, let's confirm this from the question, and I'll just read the question. Find the bearing of O from A. So that means the bearing is going clockwise around that way. Can you see that? So let's take a closer look, because the most important thing is to look at here, that vertical line there, because we know the birth of bearings begins with north. So if we begin with north, we have a parallel line, if you notice there, with a parallel line here. Now the interesting thing is we can actually incorporate some geometry in this, which is great news, because with geometry we can actually find out what this bearing is around there. So first of all, I wonder whether you notice that the angle, that if we get this angle, it's going to make the bearing so easy, and that is this angle right in there. Let me just point it out. In fact, I'm going to mark it out with a dot. I wonder whether you can see why that angle is so important that we get it. Because you know what? I wonder if you can see this. If we get that, then we can work out the bearing. Why? Because the angle of revolution, in other words, all the way around, is 360 degrees, yeah? And if we take away that dot, that angle, we're left with the bearing, which is what we're after. So that's the good news. Now let's go back to that geometry I mentioned earlier. Well, we have a vertical line there, north-south. We have another vertical line here, north-south. Now, when we have two parallel lines, doesn't it make sense we can find angle systems like corresponding angles, co-interior angles, and more importantly, alternate angles that seem to crop up in bearings quite commonly. So let's have a look here. If I want to find out what that angle is here, that angle there, see that parallel line? Then that parallel line with that line, we could actually find this angle in here, couldn't we? Let me mark that out. Those two angles are equal. Why? Alternate angles, yeah? Alternate angles, because can you see the Z there? So they're equal. All we have to do is work out this angle, and we'll have that angle. Then take it away from the revolution, and we're left with the bearing. So let's do that process. So what is this angle? Well, we know due to supplementary or straight line angles that they are 180 degrees. Let's put that in. So straight line angles equal 180 degrees. Okay, so if they equal 180 degrees all the way around and we're given 130 degrees, all we'll have to do is subtract the two and we're left with the red dot, yeah? So 180 degrees, take away what we have up here, which is 130. Let's do that. Take away 130 degrees. That's going to give us the angle of the red dot, yeah? Angle of the red dot. And the angle of the red dot is that O here, OA. Yeah? That's what we're after. So 180, take away 130 on the calculator or mentally. That equals a grand total, the angle, right in here, equals 180 minus 130. 50 degrees. Okay, let me mark that in the diagram. 50 degrees. Now, if it's 50 degrees here, it's also going to be, because alternate angles are equal, right over here also. So that's also going to be 50 degrees. Okay, due to alternate angles. So parallel lines yields alternate angles. That little line apostrophe S means angles. So we've given our reasons, so we've totally justified it. Now, our mission now is to work out what this bearing is. Now, it becomes rather easy. All we have to do is angle of revolution, take away that 50, and that will give us our bearing. So the bearing is revolution, which is 360 degrees. And we take away this angle in there, which is the angle right there in the red dot. So we take away 50 degrees. And that's going to give us a grand total of the bearing all the way around there, which is 360. Take away 50 on your calculator will give you 310 degrees. Let me mark it out right here. All the way across there, 310, that's the bearing. Let's write in what that bearing is. That bearing E right there is the bearing of O from A.